Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In today's lesson, we're going to continue looking at the standard template library, this time looking at a new data structure added in C++ 11 known as the forward list. Now, forward lists are, as they sound, give us the ability to move forward in a list and only forward, versus a list where we have bidirectional. But what's the advantage of this? Well, it comes down to space efficiency. So let's go ahead and look on CPP Reference and we'll draw it out so you can understand when to use a forward list versus a regular list. All right, so on CPP Reference, we're going to go ahead and scroll down to the containers here and see forward list was a data structure added in C++ 11. So anybody following the series using modern C++, we should be checking this out here. All right, so let's go ahead and take a look here. And from the direction here, again, it is just like a regular list here. So we have fast insertion, fast removal of elements in our container. Anywhere that we have an iterator, we can do in constant time. So the start, the end, because again, we're just shifting around nodes. It's a linked data structure. That said, again, unlike vectors or arrays, we don't have random access because we have to traverse each of the nodes in our list in order to insert a new element. And on that note, this is implemented as a singly linked list. So that's the key here. So let's go ahead and just draw that out just so we all understand here, where I have my forward list here versus, say, my regular standard list. The forward list gives us nodes and iteration in just one direction. So as you notice, every time I'm drawing one of these arrows here, that's a pointer. So I need one pointer, exactly one pointer to get to the next node. That's as opposed to the linked or the doubly linked list, which would have a node forward and backward here. So it'd be able to move in both directions during our iteration. So we can advance in either direction. So that saves us a little bit of memory in that respect. So in this way, forward lists can be a more memory efficient solution out of the box in STL. Again, if you know that you're just appending elements to a list, for instance. So let's go ahead and look at some examples so we can see how it works here. Again, you're going to see a lot of the very familiar types here, or operations that we can do on a forward list. So I think we'll just kind of dive right in and see how to use forward list. Okay, so let's go ahead and open up some code here. And again, here's how I'll be compiling. I'll be using C++ 20, though you just need C++ 11 at most, and we have our program here. I'll go ahead and do this compilation step in one, just so you can see it there. And let's go ahead and start. So the very first thing we want to do is include our forward list structure here. So with that, let's go ahead and just initialize a forward list. So in the standard library here, forward list, and we need to choose the type. Again, it is templated, and I'll just call this my list. And I'm just going to use a list initializer here to go ahead and set it up 1, 2, 3, 4. So that should create our list here. And then let's go ahead and print out the list here. So I'm going to need to write a little helper function. So again, using some of the lessons that we've learned about before here, let's go ahead and make this a forward list that we pass in by reference here. I'll just call this list. And then we'll just go ahead and print everything out. So this is similar to what we've done in some previous lessons here, just to clean up our output here. So for each of our elements, since we're not modifying them, we'll pass them in by reference here. And let's go ahead and look through our list. And let's just go ahead and print every element out, whatever the element is. I'll just call these element E. And I'll just put a comma here. And let's go ahead and print out 2 end lines here. And we're done. Okay, so let's go ahead and give this a try. Looks like we're good to go there. 1, 2, 3, 4. So now that we have our list created, let's go ahead and see how we can append elements into our forward list. Again, kind of working through our documentation here. So I have some modifiers here, and it looks like I have the ability to insert after and also push front here. Now, again, just thinking about the structure of our forward list here, this example here, again, observe I don't have a pointer to the end here, okay? So in that way, I don't have a push back or a way to quickly append to the end of our forward list. Because again, the goal of this data structure, why it was added, was to have the minimum amount of overhead, okay? So we'll look at insert after and how we can use that, but let's just go ahead and start with push front here, okay? All right, so with push front, in order to add some more elements here, let's go ahead and do my list, push front, and let's go ahead and add 0 here. Go ahead and rerun it, and we see 0 pushed in the front of our list. Now, I think it would be kind of interesting to do a little bit of an experiment here, maybe a performance experiment, to measure the actual utilization of your memory, as well as maybe performance, to see just how much faster it is. But again, if this is the type of operations that you're doing, just collecting data, for instance, in a log, consider using Forwardlist because, well, it's just a simpler data structure that's going to be more memory efficient. Okay, so anyways, that's my little tirade on push front here. Let's go ahead and look at insert after here. So insert element after an element here. Okay, also I just want to highlight push front since we're just prepending to our list here. As is noted here, the complexity is constant. So this is a very fast operation here. But let's go ahead and compare that with insert after. Let's see what we can do. So insert element after the specified position in the container. So again, this is going to look like a lot of our STL data structures where we have some sort of iterator here to the position that we want to insert, but again, after the position that's specified here, and then the actual value here. Okay, so what's the actual complexity going to be? Well, again, if I have the actual iterator, this is just a constant time operation. It's rearranging a few pointers and that's it. Okay, so this looks pretty similar to our regular list here. Okay, so let's go ahead and build this up here. Let's go ahead and try now to do another little experiment here. And let's center around here. And let's go ahead and do my list, insert after. We need a iterator here. So let's look at the end of my list here. And let's put an element here like 5. And then let's go ahead and print out our list. And let's go ahead and run this program. And looks like I got a segmentation fault. So this is kind of one of the most common things that when we're first working with a forward list, we might think about, how do I just append at the very end? Again, the point of using a forward list, though, perhaps is to just be able to push in the front and be able to do things very quickly. But that said, we still probably want to figure out, or you want some way to push back to the very end. So let's practice a little bit with our iterators. Okay, so let's just think about this a little bit strategically. And again, I think this will hopefully give you an intuition about forward list and how sort of minimal it is. But really what we'd want to do is, be able to find this n iterator and then do something like minus minus. Now that's not a operation that's supported, right? We can't reverse from there. So what we could do here is we need to figure out an iterator or the position here. Okay, so let's just actually call this the position that we want to insert after. So I'm just going to go ahead and let's just get an example that works first, and then we'll sort of move backwards from there. But let's go ahead and just say, okay, I want the beginning of my list. Okay, so let's go ahead and see if I can insert something after the beginning here. Okay, well, that gives us the position 0 and then 5 here, because we're inserting after the beginning. Okay, so again, our goal is to figure out, what that last element is, in this case, 4 here. Well, we do have some tools that, if I know what the beginning is here, that I could advance forward. Okay, so let's just go ahead and try advance position and by 1 here. Okay, so go ahead and advance by 1, and we can see that we have successfully moved it forward. If I advance by, let's just take a guess, 3 here. Well, let's see. I've found the beginning where I want to insert 0, 1, 2, 3. And then I insert after and put 5. Okay, so that's the basic idea. So if I want to figure out, where I want to insert after, well, let's see what the size of this thing is. 0, 1, 2, 3, 4, or the size is 5 elements minus 1. I want to insert after this specific index here. Okay, so, wouldn't it be nice if I had my list dot size? Let's go ahead and try it out here. And yeah, looks like we don't have size here. Again, very minimal, because inside of the data structure, we don't want to maintain size or the count of things. So again, if we look through forward list, I don't see, and let's see, oh, here we are. There's a max size, but there's no size function here. Okay. We have the type here, but just, so there's no easy way to do that. So how do we count or figure out the size? Well, we have to maintain that ourselves. So I'm going to give you a little bit of a help here, and just show you that we have distance as a potential function here. Okay. And what distance does is between two different iterators, it'll tell me the size sort of traveled, or the number of hops. Okay, so let me make that a little bit bigger so you can see the number of hops from our first position to our last. Okay, so we can use that to calculate the actual size here. Okay, so let's go ahead and do that. Now I'll just store it as a distance here. Okay, so this function distance. And in order to compute the length of our array, we need to walk through it once. So there is a cost to this, from the beginning to the end of my list here. Okay, and that is the distance here. Okay, so let me go ahead and just arrange this so you can see how that works here. So now I want to move this thing the distance. Okay, I'm going to go ahead and run this one more time, and crash it one more time here, just so again you can see, well, one, I made a syntax mistake, so let me fix that here, and I'll properly crash it here, that we're still getting the segmentation fault because again we're off by 1, right? We count from 0, so I want to advance this distance -1, so the length of our entire forward list. And then voila, now I can insert at the end. So if you need to do this, if you truly need to push back, consider that you're walking the entire list here. Okay, now we could sort of abstract this if we want. We could have a void pushback sort of function here. Let's actually just implement it here, because I think this is something that folks often want, but it's probably a case that if you're using this, you might just need a list anyway. Okay, so that's sort of the idea here, or sort of a hint that again will give you the idea of lists should really be used for a sort of expanding data structure. We're able to just push stuff on the front and not worry about it. Okay, so anyway, let's take in our list here. Let's abstract out this functionality here, and I'll put it here. And actually, we don't want this to be const, but we do want to modify it. So I'll just call it a pushback. And let's go ahead and move in our insert after function here. And let's update these to just be my list. All right. And then we'll just call pushback on our my list here. All right. And let's unhighlight those things. There we go. All right, so this is effectively one way you could get this to work if you want. And again, you see that it works just fine here. Now, of course, here, let me change this up a little bit. Let's give this a parameter here, just so this isn't always 5. There we go. Pushback 5. And let's do a few more of these here. So again, I'll say, warning, you might just want to use a standard list, but this is good practice showing how light weight forward list is. Okay, so I think that kind of gives you the idea again, and we got to see some of these functions here. Okay, so now we can see these things here. Oops, let me make sure I actually save this. And now I'll give it a run here. Oops. Save, run. Okay, and now we can see 5 and 6 are pushed to the end. Okay, so anyways, that gives us an idea and some practice with some of these different functions, learning about distance, insert after, and so on. Now with forward lists, we can also do some interesting things like You can insert a range. These are some things coming in C++ 23. I didn't talk about these with list here, or prepend. So that is to take an entire element of things and then add them into our list here. Now we do have other operations like merge and sort. So let's go ahead and play around with those just a little bit here. We can remove consecutive items here. So let's go ahead and make our list a little bit more interesting here. So sort of our next experiment. Let's push into the front here, -7. Let's see, how about -5? And then let's go ahead and call on my list sort. And then let's go ahead and print out our list, my list. Just so again, you can see that we have these operations here, and you can see that it's sorted. Let's take in another list here. And again, I'm going to use a forward list of integers, list2. Let's go ahead and add in like -2, -4, or -2, 0, 3, 4, 5. And then let's go ahead and in my list, merge in list2. And again, let's print out each of these lists here. So again, merge is going to be a destructive operation. So when I print out list number 2, it will be gone here. Okay, so here is our merged list here. I already had it in sorted order, so it merges in things in sorted order here. And then it does, in fact, destroy our list 2 when I try to print it out, right? It doesn't show up under here. Now, just to show you another kind of interesting operation here, if I do mylist.unique, that's just going to keep the unique operations. That's also available in just regular lists. So it'll remove consecutive duplicate elements, just kind of something handy to have. So looking at an adjacent element and removing it. And because we're just walking through our list one time, again, the complexity is going to be the number of comparisons that you have. So essentially the length of the list -1, right? Because you're looking at the first 2 elements, the next pair, and so on. So let's go ahead and just give this a run here after we've done our merge. And then now you can see there's no duplicates here. In fact, let me extract this out to a separate experiment here and print out our list, just so you can see that the duplicates were removed. And move this around a little bit here. So these 0s, which were duplicates, were removed. The 4s, the 3s, and then the 5s as well were removed. So again, this could be a useful thing if you're doing a lot of data processing, printing out some data, and so on. So I use that operation quite a bit. All right, so I think that's really most of the stuff with a forward list. Again, just sort of understanding the idea. We have splice after, which works just like splice, except again, we're sort of picking our position. In fact, let's just do one quick example of splice after. Again, many different overloads here. Let's just go ahead and create another list here, because I think these are, again, useful text processing operations, or not list processing operations, excuse me. So let's create one more forward list here of integers. I'll call this list3. And I'll have 1, 2, 3. Actually, let's do this 66, 77, 88, 99. There we are. So something reasonable here. And then I want to do my list.splice. And I kind of have to look at this here. The position that we want to kind of insert stuff, and then the other list that we want to splice in. So let's go ahead and let's do it from the beginning of my list. And again, this is a splice after operation. So let's just go ahead and see how that behaves here. So after the beginning, okay, let's go ahead and splice in list3. Okay, we have our position and the other forward list. Okay, so let's go ahead then and print out my list. And let's see what we get here. I'm blocking it, so I'll move out of the way here. We get, okay, -7, that's the beginning here, and then we add in our list here, okay? So again, what if I want the sort of before operation. I want to get it before this -7, which was a part of the original list that we had. Well, there happens to be, if we want to do it at the end, let me go ahead and show you the code, right? We're basically just going to reproduce our experiment here, okay? Where we go ahead and say, okay, start us from the beginning, tell us how many elements we have, get some sort of count, advance that count, and then, position that iterator to effectively right before the end iterator is marked. But with forward list, we actually have something handy here. Let's go to forward list here. And in the case that we might want to, again, put something at the very start, we have an iterator for before begin. So they did think about this a little bit here. So this makes it relatively simple here. Let's go ahead and just put before _ begin. Let's go ahead and run it just to show you how it's working. Oops, I've got to just take a quick peek at this before begin. Let's see what we have here. This would be, this is a member function, on our actual list here. So my list dot before begin. Let's say it's sort of special function that returns our iterator. There we are. And let me move some stuff around so you can see in this experiment. So now I have 66, 77, 88, 99 here. From our list before begin, for list 3, I have added the elements here. Okay. And then likewise for splice after. So again, that's just a special iterator here. Let's just do one more experiment because we're having fun here. And we can actually think about, the first and then the last position that we want to add here. So I could do something like list 3.begin. And then we would want to maybe do advance. I'll move this. Let's move these onto different lines here just so we can again see the parameters here. So our list 3 beginning. Well, let's just do sort of the default, which would be like, hey, let's just take everything. Let's start with that here. List 3. There we are. Sometimes I do this different ways here. List 3. There we are. All right, just so we can kind of see clearly what's going on there. And again, that gives us 77, 88, 99. Okay, so wait a second. I wanted the beginning here. So how do I get the beginning? Well, let's think about what we just learned about here. List.before begin. Okay, and that's a member function call. Oops, list 3. Sorry about that. List 3. There we are. So go ahead and run it. And now we get our, essentially the default behavior if we don't have our starting and ending iterator here. Because again, why is that the case here? Let's go ahead and look here at the position. So element after which the content will be inserted, that's our position. So iterator preceding the iterator to the elements to move from this other iterator. Okay, that's fine. That's our actual iterator here that I have. Oops, so let me go ahead and move just to finding this range here. Let's see here. Here's our other list. And yeah, just the first and the last here that we have. Okay. So now let's think about, okay, I've got sort of the start here. And what if I want to capture some other iterator here? And again, let's just kind of think about auto, let's call it list 3 iter equals begin, or actually let's do before list 3 before begin. Okay, so we have our iterator before we're beginning. And then let's just go ahead and advance that iterator 2 positions. Okay, and see what happens here. And that's where we want our ending iterator to be here. So list 3 iter. Okay, so we just want to see a small portion of that list. Well, this just gives us 66 here. So again, I guess I've got to be a little bit careful with these before begins. Let's just start from the beginning of our list 3 here. And then to the end here. I think I'm just going to mess that up a little bit, but... and I've got to keep these consistent here. Let's just keep this at the beginning. List 3. All right, there we go. That's a little bit better here. And that gives us, again, just got to be a little bit careful here with advancing here. I'm just kind of picking a number because I know what this distance is here. Let's just go ahead and advance towards the end here from our beginning here. And I'll go 77, 88, 99. And then for our beginning, let's do again the before begin. Position ourselves here. Oops. List 3. Wish we had the universal function syntax. Then we could actually see. There we are. There's everything there. All right. So let's see. I want just 3 of the elements. So this should give me 66, 77, 88. And there we are here. So again, we could see how we have a little bit of control there on where we might want to advance here. Now, where I got myself in trouble, and this is where I would encourage, and I talked about this a little bit in the other video, I would just create an iterator list 3 end here. And this is where next is a little bit useful. Just name these things appropriately here. So that's sort of the lesson here. Next actually returns, so then you just have the end here that you can actually store here. And then this could just be the, your beginning iterator here. So we could clean this up a little bit. And again, let's just clean this up as mentioned. There we are. So now you can kind of play around with this and figure out, the end. Now, if you want the actual end, again, we need to use standard distance, the beginning, the end, and so on. But I'm just going to leave it there so you can play around with that. You already saw it at the start, and this video has been long enough. So let's go ahead and do a quick recap here of what we've achieved. So we've learned how to, and I'll get rid of our experiment here. We've learned how to create a forward list, which is more lightweight and efficient than a list if we are just traversing forwards. Okay, so that's the idea. That's the whole point of this lesson, or knowing about this particular data structure. So we saw how we can push front in constant time. We had to write our own function for push back because, again, this data structure is so lightweight, we're not storing things like size in the actual data structure. So here is our little experiment with push back here, where we find the beginning or the position that we want to start from here. And then we compute the distance, that is how many hops from the beginning to the end here. So from our position, which by default is always going to be the beginning, we want to advance to the end. And then we insert after that position -1. Okay, so that's the idea there. Alrighty, and then after we did that experiment, then we looked at some of the things like sort, printing our list, to show those results here. Again, these are special member functions for our lists that aren't part of the generic sort function that's available for things like vector and so on. We looked at, again, merge, which takes in a full list and destroys the list that it's merging in. And this is useful for when things are in sorted order. We looked at unique to get rid of adjacent unique elements so that you're only left with one unique element. And then we played around with Splice after to show how if you want to take a part of a list, we can kind of wrestle with that a little bit for forward list. That's fine. We just have to keep in mind we have this special function before begin, which is handy for some of these operations with forward list. All right, folks, so there you have it. A little bit of a whirlwind. Thanks for your time and attention on forward list. It's a really handy structure to know about. Again, you'd be surprised that maybe a singly linked list wasn't available in C++ till 11, but here it is. And again, it follows a lot of the same conventions. So you could convert your old list to this if it will be more efficient. All right, with that said, my camera is telling me it's time to leave, so I'll go ahead and leave you with that. Feel free to engage in the comments below. Make sure you subscribe so you don't miss other lessons upcoming on the STL because we got a lot more to cover. All right, we'll see you later, folks.